Today we're going to look at section 5.5a, long division. Our objective is to be able to divide polynomials using long division. So what did long division look like when you were little? Well, you took a big number, divided it by a smaller number is usually what we had going on, and then we kind of set it up in our little quotient symbol and asked ourselves how many times is 4 go into 1 evenly? And the answer would be 0 times. So then we would look at the first two terms. How many times does 4 go into 13 evenly? That would be 3 full times. Then you did 3 times 4 and get 12. And then we would subtract to see how many are left over, which would be 1. Then we would drop down the next term. And now ask yourself, how many times does 4 go into 16 evenly? Well, that would be 4 full times. 4 times 4 is 16. And then we would subtract to see how many are left over, and we'd get 0. But we couldn't forget about this 7, so then we would drop down a 7. How many times does 4 go into 7 evenly? 1 full time. 1 times 4 is 4. Subtract to see how many are left over, and we get a 3. Now when you were little, they probably had you do something weird like this, which isn't really weird, but r dot 3, to say you had a remainder of 3. Well, what does this remainder really mean? Well, that means we have 3 left over out of the divisor of 4. So really what we get is 341 plus our remainder of 3 out of 4, or 341.75 if you change it to a decimal. But what this remainder is, it's a part out of our whole. And that's what we're going to be talking about today, is adding this on. We're never going to write r dot 3. That's what you did when you were little. So how does this going to look with polynomials? Well, it looks a little bit crazier, but what we're going to do is the same thing. We have a number divided by, a polynomial divided by another polynomial, in this case a monomial. We're going to take this and put it on the outside of our quotient symbol. Then I'm going to draw my quotient symbol, put 4x to the 5th plus 5x cubed minus 7 inside. Okay. Now what I'm going to do is going to ask myself some questions. How many times, what x squared times what is 4x to the 5th? Now it's a little different than what we did with numbers, because you want to know how many full times it goes into it. Now we want to get this exactly, because I can take x squared times 4x cubed and get this exactly. So when I do that, when I multiply my green number times the blue number, okay, I'm going to get 4x to the 5th, which is exactly what I should get. Draw my line. Now this is a part students always forget. We have to subtract these because we want to know how much is left over. If we do it correctly, I should have nothing left over. So what I'm going to do is drop down my next term. But what's a little bit different than we did with algebra, I personally like to drop down everything. And you're going to see that as the problems get a little bit harder, that's the best thing to do. So now I'm going to ask myself the same question. X squared times what is 5x cubed? Well, I need a positive 5, and you always want to put some sort of symbol here because we're going to be adding these terms up here or subtracting them. 5, but I need another x. So now I'm going to do the same thing again. 5x times x squared is 5x cubed. But what do I have to remember to do? Subtract these to see how many is left over, and if I do it correctly, nothing should be left over. But now I still have to drop down my last term, which is a negative 7. Ask myself again, x squared times what is negative 7? Well, I can't take, if I have x squared, I can't multiply it by something and get down to a negative 7. So this, in essence, is my remainder. Okay? But remember, I said we're not going to put that cute little r dot and then negative 7. What I'm going to do is write my final answer as, when I take this polynomial divided by my monomial, I get 4x cubed plus 5x plus, and I always like to put a plus sign here and then write my remainder over what I'm dividing by, x squared. And that would be my final answer. To check if you had extra time, you would always take your answer, multiply it by what we were dividing by, and we should get back our original answer. So let's try another example. Okay, now I'm going to be taking my polynomial, let's go on to our next example. Now I have a polynomial divided by a binomial. So I'm going to take that binomial and put it on the outside, x plus 2. Draw my little divisor. And then inside, I'm going to write 7x squared plus 4x minus 1. Now I'm going to ask myself, again, now you might think, well, I have x plus 2 out here. What do I concern myself with? You only worry about our lead term, so the one with the highest exponent. That's why it's really important that all this stuff is written in descending order. So I'm going to concern myself with at the moment is the x on the outside. X times what is 7x squared? Well, that's going to be a 7x. So now what I'm going to do is multiply those together. 7x times x is 7x squared. But what happens with this 2? Well, if there's 2 terms here, every line should have 2 terms. Because what I'm going to do is, in essence, distribute this 7x to both terms. So 7x times 2 is 14x. I'm going to make sure I line that up underneath its like term. I'm going to draw my line. Now this is where students mess up. They forget that our goal is to subtract these to see how many are left over. So I'm going to subtract my 7x squared and subtract my 14x. If I do it correctly, my first term should reduce to 0, but I have 4x minus 14x. So what that's going to give us is a negative 10x. But again, I want to drop down all my remaining terms. So my goal is every time I do one of these little sets is to reduce my polynomial by at least 1 term. So I went from 3 terms now to 2 terms. So now I'm going to try this all over again. X times what is negative 10x? Well, if I multiply by a negative 10, I'm going to get exactly this term. So now I'm going to take negative 10 times x, and I get a negative 10x. These should be the same. If you do it correctly, negative 10 times a positive 2 is a negative 20. But I'm going to draw my line, and now I'm going to remind myself that I'm actually subtracting these terms. If I subtract a negative, this becomes a positive. If I subtract a negative, it becomes a positive. Okay, because remember, we're subtracting these. Now, if I add these 2 terms together, they reduce to 0. Negative 1 plus 20 is a positive 19. Let's try this again. X times what is 19? Well, nothing, because this has a higher degree than this does, so I know this is my remainder. So I'm going to write my final answer. When I take this term divided by x plus 2, I'm left with 7x minus 10, plus I have a remainder of 19. That's my part out of the whole that I'm dividing by x plus 2. And again, if I was to take x plus 2 times my answer, which we just spent our last 5.3 section multiplying polynomials, if I distribute combined like terms, I should get back to my original answer if this is done correctly. Let's go on to our last example. What I'm going to do here, it's a little bit longer. I'm going to take my 2x squared plus 5 and put that on the outside. And now I'm going to do something a little bit different now for the inside term. What I'm going to do is I have negative 8x to the 4th plus 2x cubed. But if you notice, I don't have any x squareds written down here. I'm going to put in what I call a placeholder, 0x squared. It's always nice to put this in each problem. I didn't put it in our previous problems because I knew ahead of time that they wouldn't be needed. I didn't want to confuse you. But it's always nice to put them in each problem because you never know what you're going to get when you multiply your top term times what's in front. And if you don't have any x squareds, a place for them, it kind of can get jumbled up in here. So it's always nice to have every term accounted for. So the x4, x cubed, x squared, x's, and no x's. So now I'm going to go through just like I did in the other 2 problems. Ask myself, 2x squared times what is negative 8x to the 4th? Well, that's going to be a negative 4x squared. And to check, I'm going to multiply these 2 together. Negative 4x squared times a positive 2x squared is negative 8x to the 4th. Negative 4x squared times 5 is a negative 20x squared. Well, if I didn't have this placeholder, I wouldn't have a like term to write it underneath. So I'm going to put that negative 20x squared right underneath my placeholder. Go draw my line. And remember, we're subtracting this. So if I subtract a negative, it becomes a positive. If I subtract a negative, okay, it becomes a positive. So now if I do this correctly, negative 8x to the 4th plus 8x to the 4th reduces to 0. And now I want to drop down any term. Well, I don't have any other x cubes underneath here, so I'm just going to drop down 2x cubed. If I add this, I get plus 20x squared. And what I want to do is drop down every other term. So plus 6x plus 5. And we're going to do this all over again. 2x squared times what is 2x cubed? Well, I just need a 1x, or you could just write x. Again, take this and multiply it by each of the terms below. So 1x times 2x squared is 2x cubed. 1x times 5 is 5x. And again, I'm going to put that under my like term. I'm going to remember to go back and subtract each of those terms to find out what's left over. That should go away. Now I'm going to drop down every term I have. Again, this is a 20. Make sure it looks a little better. We have 20x squared. 6x minus 5x is 1x, and then plus 5. And let's keep going as long as I can find a number to multiply. 2x squared times what is 20x squared? Well, that'd be a positive 10. And then go through and multiply and distribute. So I'm going to get 20x squared. 10 times 5 is a 50. Okay, draw my line. Make sure I subtract. That reduces to 0. And then when I write my final answer, this drops down to an x, or 1x. 5 minus 50 is negative 45. And now if I look, 2x squared, it has a higher degree than my x, so I can't multiply it by anything to get it. So this is my remainder. When I write my final answer, I'm going to get a negative 4x squared plus 1x, or plus x, plus 10, plus my remainder. Take what your remainder is, my x minus 45, and put it over what I'm dividing by. So 2x squared plus 5. And again, if I want to double check if I have extra time, I could take what I'm dividing by times my answer, my quotient, multiply those together to get back what I started with. Hopefully feel a little bit better about being able to divide polynomials using long division.